programming example for juice machine. A new juice machine has been purchased for the gym, but it is not working properly. The machine sells orange, apple, mango, and strawberry banana juices. In order to put the juice machine into operation, you must write a program that shows the different products sold by the machine and lets a customer make a selection. The program should also show the customer the cost of the item selected, accept money from the customer, and release the item. In other words, the input for the program will be the item selection and the cost of the item, and the output should be the selected item. A careful analysis of the problem reveals that the juice machine has two main components: a built-in cash register and several dispensers to hold and release the products called objects. Objects combine data and the operations on that data in a single unit. Let us first discuss the properties of a cash register. The register has some cash on hand. It accepts an amount from the customer, and if the amount deposited is more than the cost of the item, it returns the change. For simplicity, we will assume that the user always deposits money greater than or equal to the cost of the product. The cash register should also be able to show the amount of money in the register at any given time to the juice machine's owners. The following cash register class defines the properties of a cash register. After identifying cash register as a component, you must define its properties. The class cash register has two public member functions: get current balance and accept amount, which can directly access the member variables. It has only one private member variable, cash on hand, which cannot be accessed outside of the class. The first function, get current balance, is constant. It returns the current amount in the cash register. The second function, accept amount, receives the amount deposited by the customer and updates the amount in the register. To do so, this function uses a formal parameter, amount in. The class cash register has a constructor with default parameters, which sets the cash in the register to a specific amount. The default value is 500 cents. And the variable cash on hand stores the cash in the register. You can describe a class and its members graphically by using a diagram known as the Unified Modeling Language Diagram. The UML class diagram of the class cash register looks like this. Next, you must define the member functions of the class cash register so that its operations can be implemented. That is, write the definitions of the functions get current balance and accept amount. In the function definitions heading, the name of the function is the name of the class, followed by the scope resolution operator, followed by the function name. The function get current balance returns the value of the private member variable cash on hand. The function accept amount accepts the amount of money deposited by the customer. It updates the cash in the register by adding the amount deposited by the customer to the previous amount in the cash register. In the definition of the constructor checks for valid values of the parameter cash in. If the user does not specify any value when the object is declared, the default value is used to initialize the member variable cash on hand. If the value of cash in is less than 0, the value assigned to the member variable cash on hand is 500. The next component, the dispenser, will release the selected item if the dispenser is not empty. Our program should display the number of items in the dispenser, as well as the cost of the item. The following class defines the properties of a dispenser. Let us call this class dispenser type. It has three public member functions: get number of items, get cost, and make sale. It has two private member variables, number of items and cost of type int. The first member function, get number of items, returns the number of items in the machine. The second function, get cost, returns the cost of the item. The third function, make sale, reduces the number of items by 1. The class dispenser type uses a constructor with default parameters which sets the number of items in the dispenser and the cost of an item to the values specified by the user. The variables, number of items, stores the number of items in the dispenser, and the variable cost stores the cost of an item. The UML class diagram of the class dispenser type looks like this. Because the juice machine sells 4 types of items, you will need to declare 4 dispenser type objects. As an example, the statement dispenser type apple 100, 65 sets the number of apple juice bottles in the dispenser to 100 and sets the cost of each apple juice bottle to 65. Next, you must write the definitions of the member functions and the constructor of the class dispenser type so that its operations can be implemented. The first function, getNumberOfItems, returns the number of items of a particular product. Because the number of items currently in the dispenser is stored in the private member variable numberOfItems, the function returns the value of number of items. The second function, getCost, returns the cost of a product. Because the cost of a product is stored in the private member variable cost, the function returns the value of cost. The third function, makeSale, reduces the number of items in the dispenser by 1 when a product is sold. That is, it decrements the value of the private member variable number of items by 1. The definition of the constructor checks for valid values of the parameters of setNumberOfItems and setCost. If these values are less than 0, the default values are assigned to the member variables. The main program is divided into 3 functions: showSelection, sellProduct, and main. The function showSelection displays the information necessary to help the user select and buy a product. The function sellProduct attempts to sell the product selected by the customer. For this, you need a variable to hold the amount entered and a variable to hold the extra amount needed. If the dispenser is not empty, you need to prompt the customer to enter the cost of the item. Then you get the amount deposited by the customer. If the amount entered by the user is less than the cost of the product, prompt the user to enter the additional amount, and calculate the total amount entered by the user. If the amount entered by the customer is greater than or equal to the cost of the product, update the amount in the cash register, and select the product by displaying an appropriate message. If the amount deposited by the user is less than the cost of the item, return the amount. If the dispenser is empty, display a message to tell the user that this product is sold out. The definition of the function main is as follows. First, create the cash register. That is, declare an object of type cash register. Next, create 4 dispensers. That is, declare 4 objects of type dispenser type, and initialize these objects. You will also need an additional variable to hold the selection made by the user. Next, call the function showSelection to show the selection to the user. Then, prompt the user to make a choice. The program uses a switch statement to sell the desired product. If the user does not provide a valid choice, the program outputs an error message and shows the selection again and prompts the user to enter a choice. Now that the problem has been analyzed and an algorithm to put the juice machine into operation is designed, let's look at the complete program listing. Before proceeding with the function main, you must place the definitions of the classes and the implementation file as discussed previously. In this section, the class CashRegister specifies the members to implement a cash register. Similarly, the class DispenserType specifies the members to implement a dispenser. In the implementation file, juicemachineimplementation.cpp contains the definitions of the functions to implement the operations of the classes cash register and dispenser type. The next step is to describe the main program. Because the data will be entered from the keyboard and the output will be displayed on the screen, the program must include the header file iostream. The program also includes the header file juicemachine.h to use the classes of cash register and dispenser type. Then, type in the function prototypes of showSelection and sellProduct. You can now begin the function main by creating an object of type cash register and 4 objects of dispenser type, as discussed earlier. Next, declare an additional variable to hold the selected product of the customer. Complete the program by displaying the information necessary to sell the product by calling sellProduct based on the choices given by the customer. After the function main, place the definitions of the functions of showSelection and sellProduct. A sample run of the program to implement the juice machine looks like this. The user selects an available juice, buys the product by depositing the amount for the item, and finally exits the program.